Hey everybody, can you hear me? Ooh, listen to that. Wow, they modulated my voice. That sounds so good and sultry. Hey everybody, my name is Eric Escobar. Today we're going to be talking about Meshtastic, my favorite thing in the world to talk about, and specifically a command and control server that we have for it, so that you can debug things remotely without cell towers, internet, or any of that good stuff. Raise your hand if you have a Meshtastic radio with you right now. Whoa, look at that. Raise your hand if you have one, or if you don't have one, but you want one. Wait, I saw some of the same hands go up. If you want them, the Rockland booth is selling them, so I would recommend running over there because they may or may not be out by the time this talk is over. So, all right, without further ado, let me spit out my gum. So I am the wireless technical lead at Sophos, previously SecureWorks. We just got bought out. My day job is a wireless penetration tester and adversarial, doing all the fun things, hacking in, breaking into all the same things. So you'll see a bit of the reason, a bit of the necessity of why we built the tools that we built. And now can also talk about them. Can I just hold this? That would be awesome. Oh, I can. Beautiful. So basics. Who does not know what Meshtastic is? Excellent. I'm glad that I put some slides in here for all of you then. So Meshtastic, you can think of it like text messaging walkie-talkies. So the idea of it is that you can send a text message not using your phone, but over the Meshtastic app or a Meshtastic device. And it's very low data rate, but very power efficient and can go very, very long distances. And so it runs off of LoRa radios. LoRa is the type of wireless communication protocol that it uses. So it's not Wi-Fi, not your cell networks. Typically runs on 900 megahertz. We'll talk about all that fancy stuff in a little bit. But really, it's ideal for long-range communication where you do not need a lot of bandwidth. You are not going to be speaking audio over this. You're not going to be sending pictures over this. This is strictly text, emojis, that sort of a thing. It's also really great for nerds. It's one of those things that when I talk to my friends that are normies that don't do computers, they see this and they're like, oh my gosh, do other people care about this? And I'm like, yeah, I'm actually talking to DEFCON. They're like, wait, so you're talking at a conference about this? Like, no one in my circle cares about this whatsoever. So it's really nice to be in a room full of people and seeing, at least I think this morning I counted 1,500 on the DEFCON mesh running DEFCON firmware. So it feels really good that there's at least 1,500 other nerds out there that like the same thing that I like. So a little bit more about Meshtastic. So the actual devices that they are. So I have a smattering of them up here, and I have you'll see dozens of pictures of the different devices that I have. If you want to talk about specific devices after the talk, come see me. I will be hanging out behind the tables at the Wireless Village, and we can talk about all the different pros and cons and what to flash, what not to flash, channels, frequencies, all that kind of good stuff. These are some of the rough outline devices that there are. So you can see this little one. It's the little green one. It's called a Heltec. Heltec is really good because it's really cheap. You can buy that for like $25 on Amazon, and it just gets you going. But it doesn't have a battery. You plug it in via USB. Then the next kind of step up is the Pocket Mesh. It's made by Rack Wireless. This is a very nice board. It's kind of like the Cadillac, and it has GPS on board, sensors on board, a little screen on board, a lot of really good stuff. It's very power efficient. So you can run it. You can run it for multiple days on a single charge. The price for that is probably like $150. And then if you're looking to build out a mesh because there's no one else to talk to in your neighborhood, your surroundings, your city, or maybe you're just way out in the boondocks where there's nobody, that's where you see the one to your right, and that is a solar powered. It's meant to set it and forget it. You leave it, and it will then repeat your messages. And we'll talk about why that's important in a little bit. Does anybody have any questions with anything that I've said so far? Because it's critical to the rest of the talk if you don't understand something. Just raise your hand and shout. Going once. Going twice. Excellent. All right, somebody did raise their hand, but it's talking to somebody else. So when you talk about other nerds that also like this, I was recently going to Legoland, and I decided to put a Meshtastic device on top of my car and just see what other nodes that I picked up. And so this is me driving through the kind of Carpinteria, LA Basin, and San Diego, Carlsbad area. So there are a lot of nodes in Southern California, which is really interesting because up in Fresno, California, where I'm from, there are not a ton of nodes. But it's interesting to see when there are so many nodes like this, you get congestion, you get different hop counts that can happen. So we'll talk a little bit more about why that's important and why when you get in kind of these dense situations, why you might want to switch to a different firmware, different type of different type of channel, different channel slot. One of the things that DEFCON, so DEFCON has their own Meshtastic firmware for just DEFCON. So when you go home, do not run the DEFCON Meshtastic firmware because you probably will not be able to communicate with anybody. But for DEFCON specifically, what they change is they make it so that your messages are shorter and faster because you don't need to go very far. Typically when I'm at home, I need to go 20 miles before I can talk to the next Meshtastic node. When you're at DEFCON, you need to go maybe the next 20 feet before you talk to a Meshtastic node. So you do not need the power, you do not need the range when you are out here, which is why they can make it in the short turbo as far as messaging speed goes. So LoRa stands for long range radio. It uses chirp spread spectrum. This is a lot of the reasons why it can get out of the noise floor. So basically, without getting way too much and deep into the RF characteristics of it, this RF, the chirp spread spectrum, allows you to basically send your communication, send your signals in such a way that even if you have really low power, even if things are, even if you only have low power, and even if the noise floor is pretty high, like DEFCON, your message can still be understood based upon the bandwidth that's out there. And so that's really what makes it ideal for what Meshtastic uses it for, which is long range, low power, type of communications. So when you're looking at it, and the question I get a lot is, well, what kind of license do I need in order to use Meshtastic, right? And for Meshtastic, you don't need any license, but you can also use it if you're a ham radio operator. So some of the differences of it is that LoRa transmits on something called the ISM band. This is kind of like where Wi-Fi and other unlicensed frequencies can transmit on. These ISM bands, you can transmit with limited amounts of power on them without any type of a license, and you can also use encryption. So that's what's really also nice about Meshtastic is that not only do you not need a license, but you can also send encrypted messages. Now, if you're a ham radio operator, you can also toggle this ham switch, so you can see licensed operator down there. Now, when you toggle that switch on, a lot of people immediately think in their mind, oh, I'm a licensed operator. If I turn this switch on, I get to pump out more power, and with more power, that means I can go farther, do cooler things, all that kind of stuff. With Meshtastic, while that is true, you could go farther, you could pump out more power, you could use 433 for your communications. You are then still restricted to what your ham license allows you to transmit, which means you cannot transmit anything encrypted over that. So if you were to switch on that option, you will now not be able to communicate with anybody else that's using Meshtastic unless they are also licensed operators. So you might get to a point where you're like, hey, all me and my buddies, we're all, licensed operators, we want more power, all those sorts of things, in which case, turn it on. But by default, if you're a ham radio operator, you might want to put it on there, but I would strongly say, do not, just keep it checked off. You already have the long range that you need and typically enough power to do whatever you want. But yeah, so if you're a ham radio operator, don't immediately toggle that on because you don't need to typically to get involved with the rest of the community. This is, it's kind of like a gateway drug radio. So if you are a ham radio operator, this is one of those things that you could buy for all of your friends and be like, yeah, there's cooler things that you can do. You can transmit thousands of miles if you just get your ham license. So this is great for somebody maybe younger in your life who doesn't care as much about radios, but you think, hey, they're a little nerdy and maybe they could get involved in it. Pick up one of these devices for them. So about the different modes that there are. So if you're looking in your setup, your configuration for different modes, basically you can set things like long slow, long fast, short medium, or medium fast, all the way through that list. You can go look at it. Basically, what that changes is it changes the speed with which your message is sent out. And so the slower that your message is sent out, the longer range that it'll go it'll go. Your message will go slower, and it'll go way farther. Now, what you can do, like what DEFCON does, is they do short turbo, which means you can get way more data through there in a shorter message time, and that's meant to keep congestion down. So by default, all the Meshtastic devices that are running the stock Meshtastic firmware, they're all long fast, and it's kind of the happy spot of long distance, but you can still, your message still gets out in a reasonable amount of time. And with that, you can basically go, I'd say, like every message might take a couple of seconds to get from one node to another node, depending on how many hops that you have in between. And really what these things are made for, they're not made for streaming data. They're not made for streaming video, audio, anything like that. They're made for getting things like telemetry data, sensor data, message data, that sort of thing across. And so if you're looking at this, this is just kind of one of the examples of what we've used it for, where you can use an app, you can see telemetry from other devices. So I have a temperature sensor, I have a barometric pressure sensor, humidity sensor, and so you have these sensors attached to the board, and so you can go look at these in the app stock default, and if that sensor is on board, you can then go read that historical data that your device has seen. So this is really nice if you are way out in the middle of nowhere and you want to place a remote node, say on a mountaintop, you want a remote weather station. I know a lot of farmer use cases where they're looking out there for like, hey, I want to put tons of inexpensive sensors out in the fields to see different varieties of conditions. You can do any of that with the stock sensors. And then if you want to go crazier into it, there's also GPIO boards typically on board where you can collect tons of other sensor data if you want to collect things like, sunlight intensity, if you want to collect, let's say like the water percentage in like the soil, like all those things. If there's a sensor that you can hook up to Arduino, you can hook it up to Meshtastic. And so that's kind of the perfect use case if you're trying to collect telemetry from something that these are very low data, but because of that, they can run off of very low power for a long time. For example, I have this device right here. It's a solar power node. If you were to cover this solar panel, it would run this rack Meshtastic device for a week on just one single 18650. So it's very, very, very power efficient as far as what it's doing. So then when you're kind of getting into this, you want to know how well is my antenna working, how well are my placements working. So there's a ton of different features when you kind of dig into the settings of the app itself. The things that actually matter most, I've done lots of testing on this, and you'll see lots of pictures in a little bit here. But line of sight is what matters the most. So the line of sight elevation, getting up and over the tree line, getting up and over the city line, that is what is going to get you as far as possible, right? So yes, antennas matter. Yes, the length of cable, of coax going into your antenna matters. But the thing that matters more than anything is you could have a dumb little, like little antenna sticking out, little SMA antenna, and it will go hundreds of miles if you get it placed high enough. So just keep that in mind when you're building out your use cases, you're building out your nodes, that the higher, the better. Line of sight matters absolutely the most. But what Meshtastic has built into it is as a range test mode. So you can basically set your device, put it in this range test mode, where every 15 seconds it'll basically send a ping out, and you can see the signal quality of it. So you're not having to wait for messages over and over, and you're not playing the game of did I receive it or not receive it. You're playing the game of what's RSSI on there to really kind of fine-tune your mesh. You may not need that when you're starting out, but this really helps to kind of tune a device before you get to the point where you're going to go one time, hike a mountain, and place it and leave it there for 18 months. Ask me how I know. So how messages are routed. So this is not like your typical walkie-talkie where it is from from one device to another device, right? So while if I had a Meshtastic device and one of you had a Meshtastic device, ours would typically go point to point and you would see it. But what this does is by default, your Meshtastic device will hop 3 times to 3 different devices to kind of get its signal out. So the messages, basically what happens is every time a device receives a message, before it repeats that message out, what it will do is it will do basically -1 on the hop count. So it will hop 3 times, and that's done in kind of the headers of the message. So it's kind of similar to APRS and how far it'll go out if you're a ham radio operator. And each message only will not retransmit a message that it's seen. So there's not going to be like a packet storm. There's not going to be like an infinite loop that's created. And you can see, so I'm located in Central California, but if you look at this map, kind of in how many hops I can get out, I can get to Northern Bay Area, which you're talking hundreds of miles away by hopping through multiple devices. And it being a mesh, if some devices aren't there, you have kind of your more stationary devices that are up on top of hills or water towers or that sort of a thing. And those are typically what are the backbone of the network, and we'll talk about that here in a little bit. Does anybody have any questions so far that they have before I keep going? Great. I'll keep going, and you guys can save them at the end, or just feel free to raise your hand if you want to talk about something right away. I am not shy. You will not interrupt me. So kind of my setup. I'll fast forward a slide. So my setup is I have this 80-foot tree in my backyard, and so I have a handheld device. So when I send a message, the message goes from the handheld device into the tree to a mountain, and that mountain down to the rest of the city. So it makes best use case out of those 3 hops to be able to send messages all around my city in the Central Valley of California. One of the things that I did do to kind of help this along is in the firmware, I modified the firmware of the one that's in the tree so it doesn't actually decrement a hop. So it's basically, what that means is that when I'm sending a message from my handheld, the message from my handheld is not subtracting 1 hop count when it's going out into the tree, which is kind of nice because that way I'm not having to go outside quite often. I can just have one of these tiny little devices just in my pocket or strapped to my phone to be able to relay my messages out. And then what it comes down to is you have the kind of the backhaul of the network, the backbone of the network, which is the routers. So devices have different device modes. And we'll talk about the modes going forward, but really what you need to know right now is that the routers are the big devices on the network. And what these routers do is they take messages, they have priority in the network, and they're typically devices, or at least they should be devices, that are placed in very high, high terrain, line of sight places, because they're what are going to relay the bulk of the messages as they come through. So as you can see, like a Meshtastic device could be this tiny little thing that I can fit in my pocket, or it could be a device like this, which is on top of a mountain that I haven't seen this device in probably 15 months since I've placed it. So that's why range testing is important, because before you go hike a mountain, go place a device, you want to make sure that the range test, your antennas, everything is tuned, and everything is going to survive. Because if this were to break, if something were to happen to it, I would not want to go climb this mountain again to go place it. And a little bit more of like kind of the specialty builds is that if you are somebody who just like, hey, I want to get involved in Meshtastic, I want to buy something off the shelf, you can just go buy the Rockland booth in the vendor area and buy something like this. If you're a DIYer and you have really specific use cases for what you want to do, you can do something like what I've done right here. So this device right here, I live in Fresno, California. It is very, very hot in the summertime, very much like Vegas. It can get 115 degrees, and you can even see that it's in a fire-prone zone. If you look carefully at this picture, there's a black scorch mark behind where this radio is. So none of these batteries can go kinetic, because if they do, it's going to cause a huge fire. So kind of one of the design principles that I had on this is under no circumstance can this cause a fire if those batteries get hot. And so what's going to make a battery hot? 115 degrees in a metal box. So this device is in a metal box so that if it were to, go kinetic, if something bad were to happen to it, the fire would be contained to that box. Again, ask me how I know. I tested it. I should have actually probably added that video into here because it's kind of fun. But the fire will not escape that box. But it being in a metal box, I tested it. Again, you test things over and over and over. And without the sun shield that you see to the left right there, it will get over 160 degrees Fahrenheit in that box, which is way too hot for your typical batteries. So what I did is I 3D printed a sunshade to go on top of it. And so now inside that box is 1 degree above ambient temperature on a 100-degree day, which I think is pretty good and pretty reasonable because those batteries have a safe operating temperature of, I believe, 130 degrees. So well within the threshold of safety there. So these routers, I place them everywhere because they allow other Meshtastic people that might be sequestered to the tiny little valley to not be able to communicate outbound. So this was one that I put on the central coast of California, and under really specific conditions, you can see that I can reach from this one node all the way up into basically South Bay and then into like northern Thousand Oaks area of Los Angeles. So you can see on here that device is pretty darn high up, and the distance that I was able to see it from was 170 miles, which is a pretty good range when you consider that can run for a week on a single 18650. This is not high power. This is, in the milliwatts, not in the watt range or anything like that. So for a ham radio operator, they might be able to say like, oh yeah, well I can hit, New Zealand from here on my QRP rig. This is like QRP if you're a ham radio operator. It is the lowest of the low power thing that you're going to be able to transmit with. So there's different roles that your device can have. So you can set these roles in the settings of your device. By default, all devices are clients. What clients do is they will receive messages and they will repeat messages. That's pretty simple. That's what their whole point is. Then there's client mute. Client mute is one that I think a lot more people should use, but they don't. Client mute is basically, hey, this is a device that's going to be in my pocket. I don't necessarily care for it to repeat to all the other Meshtastic devices that I have. You can create a lot of noise congestion if you have a lot of clients because they're all going to be chatty and talking. When in reality, client mute, what that does is it's just not going to repeat. So if you're here at DEFCON you could realistically turn on client mute and go about your day, and you're still going to receive all the messages. You'll still be able to send messages, but you're not necessarily going to act as like a repeater in the mesh, creating congestion. Now, where you might not want to do that is if you have, say you're high up in one of the skyscrapers in Las Vegas, that would be a good spot to maybe have a router or a client node, because you do care then about adding to the range of the network from there. Then there's repeater and router. They're very similar. We're not going to go into the nuances of them. But the router mode is basically something that you're going to put very high up there. It gets priority in the network. It's what's going to receive those messages and send them out. And so when a client device sees that there's a router device, it's going to say, hey, I want to get my message favorably to that router device, because that's realistically going to have the greater chances of extending the range on the network. Then there's all the sorts of fun different roles that there are. There's tracker. So tracker is kind of like, would be like an AirTag, right? So it uses a lot more battery, but it's focused on sending out telemetry packets of GPS, right? Which is interesting. Then there's lost and found. So lost and found is a really interesting kind of role, because what it does is, say you have a tiny little Meshtastic device like this. Whoa, I dropped it. It's broken. A tiny little Meshtastic device like this that weighs 9 grams. You could have this on your pet's collar, and it's going to be absolutely silent and not do anything until it receives a packet to turn on. When it receives a packet to turn on, then it's going to start beaconing data out like crazy so that you can find it. So it's nice because it's a little tracking token that you can put in a box, you can leave somewhere, you can do something, and only when it's activated, only when it receives the right packet, can then will it start sending out those telemetry packets. I'm going to try this. Let's see if I can do the downward camera. Oh, snap. So this is the tiny little seed device that is based on the ESP32 platform. But you can see how tiny that is compared to my hand. So it's, again, 9 grams, and if you add a battery to it, it's 20 grams. Nice, look at that. It all worked well. Awesome. That was great. Thank you, guys. Thank you, AV team. And so then there's a lot of other node roles that I did not mention in here. And what those are, so if any of you are in the military, you've used ATAC. I know that some people have a love-hate relationship with ATAC. If you don't know what it is, don't worry about it, but it's also ATAC compatible as well if you set it up in the settings. We do not need to talk about that anymore because I don't use it. So talking about all the different types of Meshtastic devices, I own probably one of every, if not multiples of all of these, which I've brought to DEFCON. So if you want to look at one, play with one, I have tested absolutely every single one of them out since the very inception of all of them being made. And yeah, I don't think there's a single one that I don't own. But basically there's things like the T-Beam. T-Beam have the GPS. They can run off of 18650. They're pretty popular. That was kind of one of the first things that came out as far as the device, and that's this one right here, kind of up to the top. The thing I did not like about the T-Beam, though, is that the antenna was in the middle of the board, so it was kind of funky when you're trying to carry it in a pocket or do something like that. There is the T-Beam Supreme, which rotates that 90 degrees, so that it's more like a walkie-talkie kind of style. Not a huge fan of it because it's not super power efficient. Then there's the T-Echo. The T-Echo, it looks like it would be really cool, because it has this paperweight display, but the buttons are not recessed on it. So when it's in your pocket, you can put it into DFU mode or just mess it up. So I didn't really like it from that perspective. I started 3D printing other cases, so I didn't touch the buttons, but wasn't a huge fan of it just because of how that button setup was there. But then came along was the rack WisBlock, and it's specifically this pocket mesh. It's let me see if I can do this whole deal again. It's this guy. Oh, black on black does not seem to work out well, but good thing I have it on the laptop. It's this white one here to the left. Now, the things that I like about this, GPS on board, which is great if you're trying to do, say you're backpacking, say you're hunting, say you're out in the sticks, to be able to have that GPS information that then you can share with other Meshtastic devices. That's really nice. It's very rugged. Buttons are recessed. It has like nice little points where you can like zip tie things. There's plenty of open source STL files. If you have a 3D printer, you can print all of your own cases, all of your own stuff for it, which is pretty awesome. And it's based on the rack WisBlock. What's it called? I don't have one up here. I have it over there if you want to go look at it. The rack WisBlock board is probably the best IoT board that I've played with to an extent, because it has the ability to do battery charging on board. So you can take solar input. It can charge that battery for you, and so it does all the smart. It's not going to overcharge, not going to over discharge. So it has all those smarts all built into it. Then the other part that you get with it too is it's very, very, very power efficient, which is great when you're designing IoT off-grid type of things. That's something that you really want. And then it has tons of ability to have GPIO, other type of extensible ports that you can put on there. Little snap-on sensors of every variety that you can imagine, as well as it also has a like a PoE Ethernet interface. So if you want to throw this on your roof and just power it over PoE, you can do all that as well. So that's the one that I would recommend if you're looking at one. It is a little bit more expensive. It's like $150, but it does absolutely everything that you could ever imagine. Now, if you want, they sell the Heltex. The Heltex are these tiny little boards. Where are they? Is right here. You can see how small it is in my hand, right? Very small, or it comes in that little green case. These are very inexpensive. They're not the most power efficient boards, but they're very inexpensive, and you can connect them to Wi-Fi, which is also really nice. So I really like the Heltex to just plug in, and if you're going to do development work, if you want to just connect it over serial and batteries isn't that big of an issue, I would recommend just getting a handful of these for the price because of what they are and what they can do. And that's what I built the Mesh C2 system on. So now that we have like an understanding of what Meshtastic is, decentralized, off-grid, encrypted communications, all that fun stuff. What are the use cases, right? And so by day, I'm a red teamer, adversarial, pick the cool word that you're going to put in that box. We break into places, we leave drop boxes. And oftentimes when you connect a Dropbox to a network, it works initially, and then you got to sneak your way out of the building. When you sneak your way out of the building, you might lose your internet connection for whatever reason, and you just need to send it a couple of commands, or you just want to know that it is still alive. So that's where, if you look at this box right here, this is one of our drop boxes. It's actually encased, you can't see it from the top, but it's actually a rat trap that we got from Ace Hardware. So we just put this inside of a building, on the outside of a building. No one ever wants to open up a rat trap. And so it makes it a perfect Dropbox, because with that battery, it can last, Raspberry Pi can last on there for upwards of probably 5 days or so. So it's enough time to do anything we need to do. But if we lose connection to it, we do not want to be fiddling with this on the outside of a building. So that's where we came up with Mesh C2. So Mesh C2, basically, all that it is it converts your existing Meshtastic serial interface into a command and control server. Right? So you install the script, you plug in your Meshtastic device, and now when you install it, it generates its encrypted channel, so an encrypted key, unique key for only you and anybody else to be able to that you share the key with, to be able to issue commands to the device. The nice thing is that it's an AES 256 key, so pretty strong encryption, and it's symmetric. And kind of the beauty of this is that you can send and receive your shell communications to do debug. Now, you're not going to be running Metasploit over this. You're not going to be running, NetExec over this. You're not going to be, running Responder or any of the other, tools that you would use in a penetration test or something along those lines. But you can use this to get your main connection back up and out. So whether that be LTE, whether that be, connecting to guest Wi-Fi, you can send simple commands over there to be able to do this. So this is just an example of it. So I just issued LS. Issuing LS, what it does is it first sends you a message back saying, hey, this is the command that I received, and then it will then issue the output of the command. Pretty simple, and basically this tool is not crazy sophisticated, but there's a bunch of things and nuance to it that if you don't get right can kind of suck for using it as a command and control server. So if this LS were maybe 1,000 files in a directory, it will chunk that up into appropriately sized Meshtastic messages, and it will buffer them so that if you want to see more of a command or less of a command, you can basically go through there and say, I want to see more of command whatever, right? And so it'll keep that in the buffer for 5 minutes if you want to see what your interfaces look like, if you want to get a heartbeat from it. The other thing that I like to have on this too is that it's just a daemon that's running on whatever your Linux host of choice is. And so you can just echo whatever you want. You could just send messages in a bash script. So any script that you have, whether that's catching hashes, whether that's the internet is down, whether that is, hey, your hunting cabin now no longer has solar power because a battery died. If you can configure it as a script to run, you can have it sent out now over the mesh securely. And one of the things that's nice about this is that Meshtastic, what it does is that you can go into a city and you can not have to have any infrastructure there. So if, say you were to come into Fresno and you and your buddies had your own channel set up. So in this case, you can see slot number 2 there is Mesh C2. And so if you all had this on your device, you could relay off my routers that are sitting up in the hills. The router devices, the devices that repeat, they do not need to have your encryption key in order to transmit that message. All they have are the message headers. They do not have the message contents, nor do they need the message contents. So the cool part about that is that if you're using it as command and control infrastructure, you are using an existing citywide infrastructure of a city that you may not have been in previously, and you can send secure communications, secure commands, receive commands from that without having to raise any real more awareness that there's more RF in a building than there should be. And I do know people where they would notice that there's this tiny little bit of RF in there, but they are way outside the norm. 9,000% of the time is going to be that no one is going to ever recognize this. And could you use this for data exfiltration? Sure. It's going to be really slow. You could get hashes out. You could get passwords out. Really, this is meant for debugging so that you can make sure that your device is back online doing the thing that it's going to do. Because the worst thing that you could possibly do is break into a facility, go through all the hoops to clone badges, get in, middle of the night, place your Dropbox behind a printer, bypass, whatever port security they have, all for that device to reboot, and now your key's not on board, right? So that's what this was designed for, is to be able to issue those simple commands, receive those simple commands, buffer those commands, so that you can then access it later on. And then the other thing that's nice about it too is that you can also use the daemon. So even if you don't want to do any of the secret squirrel, command and control stuff, you could still have it. So you just plug one of these little devices in to a USB port, and now any bash script that you write or any script that you write can now just be broadcasted over the mesh. And I said it, so by default, it only does send it on your secure Mesh C2 instance. But if you want to, you can just add a flag to it that says, hey, broadcast this on the default public long and fast or the public DEFCON network. So you can configure this just with a flag in the script to be able to send over any channel that you want, or even at a cadence. So if you just wanted it to say, hey, I'm still alive, here's a heartbeat, you could do that as well. And the beauty of it is that this is all end-to-end encrypted, which is very nice because it would be really dumb to make a C2 server that anybody could issue commands to. There was one time I powered it up before, and when I was doing my development work, I powered up the Mesh C2 at my local network, and it wasn't selecting the appropriate channel, and so it broadcasted on boot. It said, hey, the C2 server is up. Feel free to issue commands out to the entire public mesh. And then I had luckily I have a fairly small mesh. I know pretty much everybody in it, and so I just got a bunch of text messages that they're like, hey, dummy, maybe don't have your C2 network broadcast on the open network. But again, it was all during development. Wasn't really worried about it. It's just kind of one of those funny things where I made sure that there was a flag that it gives you a warning that says, hey, don't be dumb. Be sure you want to do this. So you don't have to worry about it becoming an accidental command and control server. Let's see. So some of the other things that are nice about the script, about the daemon that runs, is that it breaks that Mesh C2 out into multiple packets. So if you have, say you're catting a file that's going to be, I don't know, 1,000 characters, it will break that up into a logical amount of packets and then buffer it. So it will send out 10 messages by default, all broken up, like paginated basically. But then what it will do as well is that if you want more of that output, you can then type more and continue to receive that buffered output for about 5 minutes while that output stays in there. And it'll buffer it, and then you can also issue other commands on top of it, and you don't have to worry about it. It does all the nice signal handling of sending and receiving messages so they don't get, tromp on top of each other. And the other thing, too, is it queues them all up, so it creates a nice little buffer to send out the messages. So if you have multiple alerts going out, multiple commands coming back with data, it will then queue that out, buffer it out, so you don't have to worry about it. You could also there's also a flag in there that will append timestamps. So if you want to know, hey, when did this command actually come back, you can also append timestamps. The reason I don't do timestamps by default is because it just adds unneeded data that you could use for actual packets and data coming back. So I don't want to take up a significant chunk of the message that you're going to get just in the stupid timestamp. The other thing that it does too is that it will retry by default 3 times to send that message out. So oftentimes if you have one of the small little devices, one of the little ESP32 devices with like a little flimsy antenna on it, it may not get out that well. So it will then retry 3 times until it gets an acknowledgement from the other version of that command and control server. Again, these are all things that are not crazy complicated, but they're really nice to have, especially when you need that data to get out the most. So here's an example of some of the different things that you could do with it. So you could add this into whatever your bash, ZSH. Once you install it, Mesh-C2 is just executable program. So you could just say, hey, this is the message, timestamp. You can have it sent on specific channels. Again, I use it for C2, but I could recognize that there are other times where you might want to use it for other things. I have a friend who had like a chicken door, right? You could have this chicken door so that when the door is up, door is down, and it's a remote part of your property, that you get the message that says, hey, I'm going to send the message, door is closed, chickens are locked up for the night, on a specific channel that maybe isn't your encrypted Mesh-C2 channel, but maybe it's just the public channel, right? So lots of different use cases that I was like, hey, this is going to take me an extra couple minutes to add these features in, and I don't know what you might do with it, but it's in there so that you can easily and programmatically kind of send messages out over the mesh, whatever channel you want, from pretty much whatever device you do want it from. We don't need to really go into the architecture. It's a systemd service that just runs. Everything is by default is AES 256. All the commands and command output, they are all logged into the device by default. You can turn off that if you don't want them to. If you're using a Dropbox, I understand maybe you don't want to fill your device up with just random mesh logs. But it is nice because if you are concerned that somebody issued commands or for whatever reason you just want to audit the commands that were sent over this device, they are all fully logged. All the commands, all the responses to those commands are logged to the device itself in the logs directory, which is, again, not an astounding feature. It's a very nice feature though when you need it. So some of the features on it, so you can do it in so if you don't do the -- real device mode on there, then you can just kind of simulate as if a mesh device were there. You can create different channels. You can basically just use this to create list channels back. You can use it as like a easy way to back up and restore different channels and different configurations if you didn't want to do it through the app. And by default, when you do install this, it does generate its own AES 256 key for the channel, so you don't have to worry about key reuse or something along those lines. And honestly, it's just cool to be able to send messages from your terminal out to the mesh. There's tons of other use cases. I actually use this as one of the challenges in the wireless CTF to transmit flags and do that kind of a thing too. So if you're playing the wireless capture the flag, then hint hint, this is what I'm using to send out different flags for some of the Meshtastic challenges that are out there. If you want to know more, check out Meshtastic.org. That has basically all the libraries, all the information you could ever want. If you want to know more about our local mesh, it's fresnomesh.com. I have links to pretty much everything that I've talked about in here. And then if you want to git clone this project, you can make fun of how terrible my agentic coding is, or I should say ChatGPT's coding skills are, by checking out Mesh-C2. Again, this is really a tool that I built for myself. And then after I talked to some friends, they're like, okay, you should tell other people about it too, because it's kind of cool and really nerdy. And thank you for sitting through my talk for the next 45 minutes. Does anybody have any questions? Anybody? Anything? You can also just come see me at the booth too. I see a question right there. Could you use it as a back-end connection to an OMG cable? Yeah, you actually could. So if you had a basically a middleware device, so kind of like a Dropbox. So when we're gets out of the Meshtastic realm, we're planting devices in networks that we have permission to, networks and physical spaces where we have permission to put things like OMG cables, things like keyloggers and all that kind of stuff. If you have a Dropbox that is able to receive information from that OMG cable, you could absolutely then use this C2 infrastructure to get that data out as well. As long as it's not a lot of data and it's just some text data, but keyloggers would be perfect for it, provided that your user does not type, professionally at 100 words per minute. That's a good question, though. Yeah, I hadn't thought about it. And again, that's why I built it out, because I don't know what your use cases might be, but that is a totally legitimate use case for it. Anybody else? Going once? Going twice? All right. Well, if you do have a question and you don't want to announce it to everybody, feel free to come see me at the Village. I live, eat, and breathe Meshtastic, LoRa, and low-power gear. So thank you all. Appreciate it.